Bueno, buenas tardes. Antes de nada, gracias por venir a todos. Este evento es y para técnicos, ¿vale? Dentro de toda la comunidad de API Academy, ¿vale? Nos encanta haber podido traer a Ronnie Mitra. Gracias por venir. Thank you for coming, Ronnie. Viene directamente de Vancouver, con lo que se ha pegado un palizón y, bueno, pues, entonces aprovechemos entre todos a su exposición y hacerle las preguntas que queráis. Aprovechemos la ocasión. Después dejaremos unos minutos para lo que sea el tiempo que sea necesario para hacer vuestras preguntas. En acabar, después os invitamos a tomar unas cañas aquí en el bar de al lado, o sea que también es una buena excusa para quedar. Y también nos hemos dejado la urna para los que no son ni de CA ni de Gfi, pues para el sorteo de este fantástico dron que tenemos por aquí. Entonces, bueno, pues hay más posibilidades que os toquen el resto. Entonces, bueno, tendremos que hacer algo. Entonces, bueno, sin más, os dejo con él. Ronnie, when you want.
Thank you. I heard Vancouver. What was, where I'm from? Oh, okay. Oh. Ah, yes. No, not today, but day before yesterday. And I thought I heard something else. But this is who I am. I'm Ronnie. As you can tell, I speak primarily English. Apologize. But I'll try to speak slowly so that everyone can understand. I'm part of this team, the API Academy. First, a question for you. Have you heard of the API Academy before today? That's more than usual. So 2 people. I'm actually, this is not a company. So the company I work for is CA Technologies. But we're a team inside of CA, but we're a little bit different from other teams from software vendors you might meet. So CA sells software. What we do is we help people build distributed applications. We help them with architecture. And CA allows us to do this without selling software. So I'm allowed to talk to you today. There won't even be a slide that says, and these are the products that you can buy. Okay? So this is the nice thing about the group I'm in. There's only 4 of us. Myself, Mike Amundsen, who's based in the United States, Eric Vilda, who's based in Europe, and Mehdi, who you might know if you've gone to any API conferences. Mehdi runs the Appy Days event, so he's part of our team as well. And really, what we do is we do research, we write, we do a lot of presentation talks, we organize the community, so anything in this space. Lately, there's been a lot of focus on microservices, and we've been helping people with that. But GFI, I guess we would pronounce it what? JFE? What's? Okay, that's the best I could do. They asked me to come and do an API type talk. So I went through my list of subjects and what people always ask me for. And I think what seems to come up a lot, please. What seems to come up a lot at the moment is, if I'm making an API, what is the best API to make right now? Which is not a question I was necessarily getting a lot of before. So we're going to talk about API styles. I think the challenge we have is that there's all these technology changes. So we hear about Google RPC, or we hear about GraphQL, right? A few years ago, we had that shift from SOAP to something else on the web, right? Whatever that meant. And we kind of started moving towards this. But over the last year or 2, there's all of these other things popping up, and it's becoming harder to decide what our API should look like. And just to note, when I talk about APIs or APIs, I mean any of these things. So for me, API does not mean just this URI and HTTP method, right? API is really any interface that allows the software components to talk together. But I'm going to talk to you about styles. If I ask you to design a house, like let's forget about software for a moment. If I say let's design a house together, you can make this house in almost any way. right? The houses I see in Spain look very different from the houses I see in the United Kingdom. I'm from the UK, by the way. The only thing we have to be careful of is things like the building code, make sure the walls are strong, right? The electricity is safe, but the style is totally different. But if I ask you to design a particular style of house, in this case a Victorian style house, you might make something that looks like this, right? But there's no set of rules for the Victorian style or Edwardian style. Instead, it's something more abstract, right? We group together these things that are the same, similar, and we call it a style. And that's what we're going to try and do here with APIs. This is different from standards, right? Standards are, we get together as a group and we make the rules. And everyone who follows these rules conforms to the standard. And we have so many of these standards, right? The SOAP standard, HTML standards, WS security, HTTP, and these standards are very important. I know that if you follow the rules, I can talk to you in a certain way. I know that if I conform to HTTP standards, I get the benefit of that standard. But styles are different. When we're talking about styles, we're talking about characteristics, qualities. I use this example of Victorian style house. I actually don't know very much about the Victorian style, so I Googled that picture. I don't know if it's really Victorian style, but from what I understand, it has kind of these kinds of arches, maybe. So that would be a characteristic. I don't know to what degree. I just know it should be arch-like. There's a vocabulary to a style too. We often use the same kind of words. So you'll notice when we're talking about certain kinds of APIs, we use the same words when we're talking about them. And maybe most important, we have a set of constraints. Each style has some rules, not formal rules like standards. We say, if we're doing something in the RPC style, right, it should behave a certain way. There are boundaries. So why is really any of this important? You know, this loose set of rules, being able to identify style. What we try and help people with in the API Academy, in the API Academy, is to help understand the model. So on one hand, the problem you have today maybe is, do I build a SOAP API, or Apache Thrift API, or GraphQL, or something called REST? What we're going to try and do is talk about these not in terms of the specific example, but the group, the style. If we can understand the different styles a little bit better, maybe you can make a better decision about which API to use when. We're going to go through 5 of these styles. Tunnel style, URI style, Hypermedia style, query style, and the event-driven style. Not in a huge amount of detail. I'll probably spend 10 minutes on each one. If you're really building software, when you're doing architecture, you'll need to go deeper than 10 minutes. But the idea here is to take a tour of these 5 styles and talk about what makes them good, what might be challenging, and how they are different from each other. And by the way, some of these terms are just terms that we use internally. So if you go to someone and you say, do you do a URI style API? They may not know what you're talking about. Okay. We're going to talk about these styles in terms of these qualities also, right? This is what we often care about as architects. The scalability of an application could mean a lot of things. What I'm particularly interested in is how many new components can I add? So not just scale in terms of scaling to meet demand, right? Instances, not just in terms of this elastic cloud stuff. But if I have a client-server interaction, can I add many clients? Can I add many servers? What happens? How does the style impact that? We'll talk about usability. For me, for this kind of work, I particularly care about how difficult it is to write the code. How hard is it to write client code? How hard is it to write server code? There are other kinds of usability you might care about as well. I won't talk about today. Things like the difficulty of monitoring an application, of deploying software, right? The operationalization of software. We probably won't go too far on that. I'm really going to focus on, does it make it easier or harder to write application code? We'll definitely talk about changeability, right? How easy is it to introduce change into software, depending on how components interact? We'll touch on performance of the application overall. And lastly, there's this idea of reliability. Does the style you choose make your software more resilient? That means if something goes wrong, does the software keep working? Or when something goes wrong, does the software break? Okay, so keep this in your head. I won't necessarily explicitly call out these qualities every time, but this is what I use as a gauge when I evaluate a style. Okay, we're going to start with this style called the tunnel style. Has anyone here done any work at all? Yes, right? Has anyone here done architecture work? Are you software architects? Would you identify as a software architect? Would you identify as a software developer writing code? Okay. I won't ask about the other categories. I think we got most of us. How many of you have worked with SOAP messaging? Okay, most of us. All right. I never used to ask that question, but nowadays, often I've noticed I'm meeting people who have never even dealt with SOAP, right? There's a whole generation of developers and architects who have heard of it but haven't experienced and worked with it. The tunnel style is primarily the SOAP style. So when we're talking about tunnel style, we're talking about SOAP. But the interesting part here is we're talking about the style, not the instance. So this isn't about SOAP. This is about this style of working with an API. But you can use SOAP as the example in your head while we're talking about this. It's called the tunnel style because what it does is it uses a protocol for transport of data, right? For example, we can use HTTP, so I can talk to a server. But our API has its own application layer protocol. So SOAP, for example, defines all of these messaging features. And I don't have to use HTTP to send a SOAP message, right? It's not a requirement. In fact, there's very little dependency on HTTP with the SOAP protocol. It's also primarily an RPC type of interaction, a remote procedure call interaction. And there's lots of examples of this. XML RPC is certainly not the earliest form of the tunnel style, but it's kind of the precursor to SOAP, which came out in 1999. We've gone through a few iterations of this. There was something called JSON RPC, which didn't really take off. And then nowadays, I would put something like Google RPC in this category. Right? So something that, you know, we thought there was SOAP, and then there was this new way of interacting. The idea of a tunnel RPC style interaction hasn't gone away. So that's why it's important to understand the model, the styles. Usually this kind of interaction is very type driven. What that means is we have an interface where we actually say, when you send a message, there's going to be fields, and each field has its data type. Maybe you're going to send me a message. Let's imagine an application, a classroom application. So we have lists of students, teachers, classes. When you send me a message to add a student, you're going to send me the name, and that's going to be a string, the age, that's going to be a string, etc. So we're going to define all of this data. This is a key characteristic for this kind of API. In SOAP, we would do that with something like a WSDL file, right? A WSDL file. It's also very procedure-based. This is kind of the RPC element. So for our application, the classroom application, when I design this API, I'll think about the functions that the client wants to call. add a new student, enroll student, that might be the name of my operation. Enroll, to put them into the school, enroll student. And it's really similar to the way we program in languages like Java or C. If you can program in Java, you can call one of these RPC type of interfaces. And sometimes that's what we love about them. The primary constraint for this style is that we have this abstraction, that I'm not dependent on the transport protocol. Right? I can send a SOAP message over HTTP. I can also send a SOAP message, the same message, identical message, over TCP/IP. Now there might be some binding differences, but the message itself, which has all of the things we care about, stays the same. Here's a common implementation model. This is usually how people do tunnel-style APIs. We often start with a definition, some kind of definition. So this contains all the types, the signatures, the operations. From this, we use tooling on the client side to generate a proxy. So we're often generating code. Now, I'm not saying every single use of SOAP and Google RPC and Thrift and all these things goes like this, but 99% of the time, we end up in this space. You give me the interface definition, WSDL or IDL or whatever it is, and then using some tooling, I'm going to generate a piece of code. And now I can call that piece of code locally, and it's going to make the call. And often we're doing the same thing on the server side. I create the interface definition, and I use my tooling to create a proxy on the server side. This is kind of the nature of RPC, right? For the developer on the client, we're giving them the illusion that the network does not exist. They make a local call to the proxy, and through the magic of the protocol, they get an answer locally. This is really what the point of RPC is. So two things to keep in mind. We have this tooling that's really based on the definition, and we have this idea that it's RPC, the network doesn't exist. Here's the good things about using the tunnel style. That way of thinking about an interaction feels so natural to so many of us. If we've spent years programming in these languages like Java and C, if I say to you, to call my API, you just have to call a function. For example, enroll student, and you pass the name of the student. That feels so easy. I don't have to learn anything about HTTP, about networks. It's just easy to get going. This support for different networks is also very valuable. People stopped talking about that value with SOAP specifically, but it's huge. So I've worked at banks where they take the same message and they receive it on HTTP and drop it into MQ, and they keep going with it. The same message, right? All these hops. And then lastly, there's this opportunity for optimization. I'm doing this kind of point-to-point client-server interaction. And because I'm essentially doing a function call, I can optimize that call. I can make the message very small. It only needs to contain enough to do the procedure. You could make the argument that with SOAP, we had a lot of other stuff, so the message wasn't optimized. But with things like Google RPC, we see you can make really small messages, right? But it conforms to all the other parts of the style we've described. There's some problems. It's transport agnostic. It doesn't depend on HTTP. It also doesn't get the value of HTTP. Right? So HTTP has things like caching built into it. Chances are if you're doing this style of API, you don't get to take advantage of all of that. Now that depends on the implementation, of course. It depends on the binding. But generally, we lose some of the feature set. The second challenge is there's often limited tooling in mobile and web spaces. Now this doesn't mean you can't build mobile applications that use this type of API. That's not what I mean. What I mean is when I start programming in with Android or iOS or in the browser, I get HTTP right away. What I don't get is all the code I need to make a SOAP call or to make that other kind of RPC type call. Right? This is another layer I need to add. And in the case of things like SOAP, it was just not familiar to people who worked in that space. And then lastly, and probably biggest for us, is the changeability. If what I said to you is true, that I create an interface language and tooling allows us to generate code based on it, what happens when I change the interface definition? It means I have to generate code again. Again, this is implementation dependent. The amount we have to generate again depends on how we implement the interface language. But taking the case of SOAP, for example, cost became very high for changes. When I change a WSDL, if there's 6 people using the service, they all have to recompile and make changes. And suddenly we're managing all these versions everywhere because the cost of change is so high. This is where we are today for the most part with what we'll call the URI style. When I say API, most people think about this today, especially if I say web API. This is that style of API where we point to something with the URI or URL / students, and then I apply the CRUD pattern. Create, read, update, delete. Right? This primarily uses HTTP. When we talk about this kind of API, we're talking about HTTP. I don't even have to say it. We just know. We're going to be talking about gets and puts and status codes. So it's very HTTP centric. If I called it the CRUD style, we could probably say it's somewhat transport agnostic, but this is also dependent on that idea of the URI as the resource identifier. Right? It's much more of an object-based design. So with the tunnel style, we talk about procedures, functions, enroll new student. Here we would just figure out what the object is. Is it school or students or classrooms? The other difference is, in the tunnel style, we're often very standards heavy. The SOAP stack gives you lots of features. Or I use protobuf in the core of the Google RPC stack. But in the URI style space, a lot of convention. Right? There are standards, but they only take you so far, and the rest is up to you to decide. And if you've done any coding with data object, it's very similar to that style of coding with data object introduction. So here's the primary constraint. You get to do create, read, update, and delete on any resource you can target. So if you can target a resource, you can CRUD it. It's simple, and that's part of what it makes it so nice from a usability perspective. I can teach you how to use an API if I can just teach you this. That's powerful. So here's a simple example, just in case you've not seen this kind of API. This is what I'm talking about. Here's the resource. We do a get on it. We establish that HTTP GET will be retrieval, almost always the case. And the server is going to send you back a collection of records. We can infer so much from this, right? Just with this information. I might say to myself, what if I want to add a student? I know that if I just put something like post, that will probably do it. I didn't read any documentation, I can guess, right? This is the beauty of the system. We need less instruction, less documentation. We can try things and they usually work. The stack looks like this. We have HTTP on the bottom, URI spec, and then some kind of data format on top. Now here's the interesting part. There's a lot happening here in the HTTP spec. So if you design APIs this way, you really need to know HTTP. The URI spec, and URIs are so important to the style because this is how we identify a resource, actually doesn't tell us a whole lot. It tells us that there's slashes and some special characters. It says URIs can be hierarchical, parent-child, right? But it doesn't tell you if a URI should have capitals or lowercase or singular, these kinds of things. So there's a lot of convention here. And then last is this data type. The data is actually not often that highly specified in the way it was in the tunnel style. And in fact, most people are not even making a decision here anymore. I might as well remove that because no one's doing an XML API or CSV API anymore. Everyone's just doing JSON. And probably not going beyond that, right? JSON, just some JSON stuff. When people implement this, this is usually the model. We've got a server with targetable resources, so I can identify a resource with URI. And really what's happening is we're passing objects back and forth. When I get from the server passes me an object. When I write to the server, I send an object to the server, right? So we get these objects going back and forth. And each object has an address. That has some implications. One of the things that's kind of evolved is people have a model in their heads right now of what an application looks like if it's client server. And most people's model looks something like this. If we're building a mobile application, we could say there's lots of parts to it. Without getting technical, it's the layout, text, images, handling touches and swipes, and what happens when you touch and swipe. Out of everything I said, it's all at the front. And the only thing people are using the back for, the server for, is the data. Right? So there's this very data-constrained pattern that's evolved. It's the front end that does all the work, that makes all the decisions, and we just use the back end to get the latest thing of data or to update the back end with data that's changed. This pattern works really well for that model. Right? If we're saying that what our back end is for is just data, I'm giving you a pattern that's CRUD, which is great for data. Right? So there's an enormous benefit here. The other nice thing is, when I say URL, URI, I didn't have to explain to you what that meant, I don't think. Most of you probably would know right away when I said get is read, or that you create a student, maybe for a lot of half of you post popped up into your head. These are things people know, they're familiar. So it makes the usability of this very good for client developers. They can understand it. And we've evolved to have a really good ecosystem of tools for this style that we didn't have a few years ago. A few years ago, you're probably using your browser just to try out the API and writing code. Now you have everything from a very mature specification language and open API spec, to testing tools, deployment tools, frameworks in just about every single language. So it's all there now. So this is kind of the de facto, someone says API, they're thinking this, because all of that's there. But it's not perfect. The first problem is that I am only giving you CRUD, and that's it. So if we're building something like an email application, some of that's very credible. Create new email. Some of it is not so credible. Perform spell check. There's no HTTP method I can map to perform spell check. Right? There's no spell check method. Now, in truth, people find ways around this. Right? I'm not saying if you do the URI Style API, you can never do a spell check. But the way around this is usually to sprinkle a little bit of RPC. Right? You use post, and you make an RPC endpoint. We're kind of getting away from that original style. And the other huge problem is that we end up with many APIs that do the same thing that are different. Sometimes I teach classes. And in that class, I usually do a lab where I ask people to design one of these. And I put them in groups. And I give them the exact same problem. Make a to-do list API. Like, here's my to-dos for the day. No one has the same API. Right? Exact same, very simple domain. Sometimes the URIs are different. Sometimes they choose different methods. Right? Sometimes the message formats are different. No one has ever produced an identical API across two teams. So it means we have a problem. If I build a client, it only works with your API. To work with another API in the same domain, I have to change my client. When we're talking about inside your company, the way people have tried to address that is with things like style guides. So we standardize on the convention, right? We say, in this company, URIs are always pluralized and they never have capitals. And a post means a create, And when you receive a collection, it always looks like this. So you can do that, and that can help. It becomes harder when we talk about external domains, dealing with partners, public developers. In some industries, there's an attempt to standardize in there too. So maybe we say for banking APIs, this is what the API looks like. But of course, the more you do that, the harder it is to innovate within. And the reason this style is more convention driven is people wanted to be able to innovate. They wanted the freedom to change things how they wanted. There's some real technical challenges here too. We talked about object passing. That can be chatty. I'll give you an example. Our student classroom application, if I want to move one student from this classroom to a different classroom, how do I do that? Maybe I retrieve the list of students, then I delete a student from the classroom called A, then I add it to the classroom called B. Right? That simple case has a lot of operations. Where with the tunnel style, I might do that all in one. Move student, and I include the details of what I want to do, and it all happens. What about building a dashboard for a UI? If I have 6 parts for the dashboard, and each of those are an object, that's 6 gets, right? So you're constantly fighting this, trying to figure out what the best object design is to be optimized for performance. And that gets harder with the more clients and scenarios you support. The last problem here is there's still a cost to change. You could argue it might be less of a cost than with the tunnel RPC style. If I start changing the API, if I add a new resource, no client is going to use that resource unless the code gets updated. So there's still a cost. This style tries to reduce that cost, the Hypermedia style. How many of you are building Hypermedia style applications today? Is there anyone? One. Okay. And really, that's huge growth for this space, right? If I asked that question 2-3 years ago, there's no hands. And today we have one. In a few years, maybe 2, right? This is really an API with Hypermedia features. I mean, that's the simplest way to describe it. Hypermedia is, at its simplest, about linking information together, right? Being able to show the connection between 2 pieces of information and letting people navigate between information. You do this with your browser all the time. When you want to learn about something, you have a starting page, maybe you start with a search engine, you follow the results, you follow a link to the results, and then you navigate within that website. The idea here is to deliver the same kind of experience to machines. If you browse the web the way that you program a URI style application, you would find yourself constantly going to the address bar and typing the thing that you wanted to get. And you'd have a list of all the resources somewhere, either written down or in your head. That's the way people program URI style applications, right? We memorize all the resources and we memorize how to deal with them. That's coded into the app. In this style, we do away with that. The client follows links. The server instructs the client about what it can do next and about how it can interact. The classic example of this is really Roy Fielding's dissertation with his chapter on REST. You notice I haven't really said REST as one of the styles, and that's really only because it's a bit controversial, right? To call something REST because it has different meanings. I leave it up to you to decide what REST means in your organization or in your head. But when I'm talking about the Hypermedia style, I'm really talking about Fielding's REST here, as he defined it. When we build applications this way, we focus a lot on transitions, how I go from one state to another state. And the big thing is that URI is not the key here. It's not about constructing a URI. Now, that doesn't mean that URI is not important. On the server side, the URI is still hugely important, right? It's how we know what the client is asking for. But just like when I use the web today, if I go to Google Maps and I search for things, that URI gets really long and it's obviously useful to the implementation, but it's not useful to me as a user. I don't care what's there, except for the fact that it's https google.com. Everything after that is insignificant. It should be the same for client applications. The URI is important but not meaningful to the client. And lastly, this is the key idea here, that the messages are self-documenting. So the responses I get from the server tell me at runtime how I should interact with the API. It's a pretty simple idea, but in execution has some interesting challenges. So the primary constraint here is the uniform interface. This is what makes this style different from the others. And this is how Fielding defines it, obviously with more words, but he's got these 4 parts. If you're building URI style APIs, I think you're probably doing the first 2 things. You are identifying things with the URI, right? So you're identifying resources. And you're definitely manipulating resources with representations. The request message, the response message. These are abstractions of the actual resource on the server side. To get to this style, you'll have to incorporate these other 2 parts that Fielding defines. Self-descriptive messages and hypermedia. This hypermedia feature. The stack in hypermedia looks more like this. It doesn't have to be HTTP. Right? You need a uniform interface, but it doesn't have to be HTTP. You'll often have a media type. So instead of just saying JSON, you're going to decide, most likely, how something like a link should be represented. And if you use a standard for that, that makes it easier for everyone to interact, right? And then on top of that, you might even have some semantic definitions, some meanings for words. So you might start incorporating other resources, saying, hey, if you go over here, here's the list of words we're going to use in the API and what those words mean, to make it easier to navigate. Yeah. Oh, CoAP, the question is, what is CoAP? CoAP was a protocol that was started, and I think largely abandoned now, for the Internet of Things space, and it was intended to be RESTful. I think it's largely been supplanted in actual use by MQTT, so it was that same kind of space. When you implement this kind of style, usually it's something like this. I somehow get the server to send me a message, and this server is going to send me data, but also links, right? And I'm going to follow links for navigation. If I want to send data to the server, often I'm going to send that using some kind of template. The server will send me a template, and I'll fill that template in with data. So here's a classic example of hypermedia, right? This is HTML. The biggest, most successful hypermedia, maybe software application ever, using the web with a browser. So we can see this is obviously a link. I'm going to show you, like, step by step, how we might take a message we're used to and turn that a little bit more into hypermedia style API response. If I ask for a particular student record, a URI style API might give me this, right? I think we're all on board with that. A bunch of JSON data. We could add something to that data, right? I could say, if you want to know the address of the student, there's this other resource you can retrieve. So I call it address details. So I have this special key, and the client application knows if it follows this, it can get address details. There's a lot of assumptions I just ran past, right? One is that the client somehow knows that this thing is a link when it's called that. The second is the client knows how to interact with this link, that, oh, it's going to be a get, for example, and this is the URL for that. And the third is, depending on the application we're building, that someone knows what an address is, right? Is that meaningful that it's an address? Depends. So we could take this a step further. I have a lot of data here. We could also take that data and genericize it a little. So I could start templating the data itself. I could say the data you get in response is actually a set of name-value pairs, and these are the names and these are the values. It's more complicated, it's less usable, harder to look at, but it might give you more flexibility. It might give you a way of building a user interface more generically, for example. And I might say, you know, this thing, address details, is not generic enough either. So instead, I should have just a place for links, right? So I could take that same link and genericize that as well. So now the client just needs to look for this keyword links, and it will find links inside of there. If you start designing a media type or start playing with hypermedia, this is the road you kind of go down, right? Little by little, you start solving these problems of how to make software in this way. A big part of it is understanding that there's kind of a state machine inside. At least that's how I think we should look at it. And it's the state of the application, right? It's the state of the client server together. So when I get a list of student records, I'm in a specific application state, and from there I can move to other states. And the server is going to tell me which states I'm allowed to move to. But I might just disrupt the whole state machine and go somewhere else entirely, right? You have to be ready for that as well. Going back to that model we talked about, how we perceive client-server software. Here's one way we disrupt that model in our head. If we have a case of a hypermedia client that's primarily a machine, so there's no human driving this, talking to a hypermedia backend, then what we end up doing is having data, but maybe also application logic back here. So the backend is going to tell us what we can do next after we retrieve the weather for a city. Maybe it gives us a list of other cities we can retrieve weather for. On the front end, this client, we're going to have some application logic too, right? Because he's going to have a goal of its own, but probably also some semantics. For me to interact with this thing, I'll need to know some words so I can pursue my own goal. Now the difference is, when I say semantics here, it doesn't necessarily mean that the thing you write has to understand the universe, right? I think for a lot of us, when we start looking at this style, one of the challenges is, do we have to build these artificial intelligent clients? The reality is you need enough semantics to meet your changeability goal. So I could define some semantics that just pertain to this weather domain, and that would give me a degree of changeability. Obviously, the more semantics I can build in, the greater the changeability, right? But you don't have to start with science fiction. You might also build a human-facing client. So I could have a mobile app with most of those parts we talked about, right? I build my own UI, but the back end gives me data, and it tells me what I can do next. I paint the screen myself. I decide how it looks. I decide the layout. And I could build different UIs. And then there's this third model, which looks like this. We've got a really thin client. Really, it just handles the touches and the swipes, and everything else is happening on the back end. You can even think of this as the back end builds the page and sends it, and the front end just handles the interaction. We might even have very little semantic knowledge on this client. It's the human who's using it who understands what the sun means, right? The client doesn't need to. So there's three models of building hypermedia applications. Each of them have their own special, unique challenges. They probably all three look very different, but underneath them is this idea of the hypermedia API. And the reason you do this is because you want to reduce the cost of changeability. If you don't care about the cost of change, this is not a road I would suggest you should go down. And it definitely favors long-running and larger scale applications. So ones where we will have perhaps many clients or perhaps many providers. Applications where we want to deploy a client once and we don't want to have to change that client code for many years. Right? These are good use cases for working this way. And this whole thing about REST is really a formalization of what makes the web work the way it does. Right? The decentralization, loose coupling nature of the web is idealized in the it's not perfect, right? If you're just building something dirty and quick, or you don't care about the life of this application, this may not be the road to choose. If the cost of changing clients, for example, is very cheap for you, maybe this is not the way to go. A lot of people just naturally get turned off because it feels too hard. It sounds too hard. Like no one can really do this. And I will say at the moment, clients are not trivial to build. So you have to put some thought into this. Right? Sometimes you're kind of exploring the edges of things. From a performance perspective, compared to other styles, these messages might be a little bit bigger, fatter. For example, servers have to provide links. Right away, we're adding data to the message. In HTTP and in this style, the messages are supposed to be stateless, so we're including more information in every transmission. So if constraining message size is important to you, this may not be the best style. There's a lot of good things about hypermedia that make it worth exploring more. Okay, let's move on to a style that I would not have talked about in the past, really. That's the query style. It always existed, but it's the advent of things like GraphQL that have made it suddenly interesting to us. The query style is pretty simple in terms of understanding it. We're going to have a query language, and that's how we're going to deal with the backend. We'll define some language for executing queries, for examining data and retrieving it. And there's a long history of this stuff. Sparkle, OData supported this. There's little experiments like Quillio. But GraphQL certainly has caught everyone's imagination. With the query style, we treat the API as a data source. And I execute queries against it. Right? This query language is obviously very important to this whole idea. In fact, it's really our primary constraint. Right? Whatever that query language lets us do, that's what the API is. So if the query language is very poorly defined and doesn't let us do very much, then that's how useful the API is. If the query language is very confusing to use, again, that's reflected in our usability for the API. Here's an example of a GraphQL query. I actually really admire how they designed it, because the simple idea that I define the shape of data that I want and I get that back, this kind of symmetry, is quite appealing. One of the things we notice is that to do this, they have to use something like HTTP post. I believe you can use a GET in GraphQL, but typically for things like queries, you want to include a body, because your query is going to have data, right? So we end up in the world of post, which for HTTP has implications. So it's a little bit RPC-like. The procedure here is run a query, right? That seems to be what we're doing. In terms of the stack, there's a query language and there's a protocol. In between, I think there's kind of an unspoken data model happening as well. So there's the data we're defining in terms of this is my data on the server, and also just the nature of the model. If I build a query interface language based on things like tuples, that's going to have implications. Keep in mind, when I say data model, that doesn't necessarily mean how your database looks. When people use this style, to be effective, they usually have some kind of abstraction. So there's a data model that exists just for outside people that may not be the same as the database structure, right? And part of your challenge is you'll have to bridge those two worlds together. So there's often some kind of transformation happening. People are asking for queries. To serve that query for that abstract data model, we need to go out and get real data sources from lots of places. Also, there tends to be some kind of query client involved too. Although technically, I think you could just call the query in a raw way. When I think about the style, to me, honestly, it's very similar to the CRUD style. And a lot of the benefits are similar. We're talking about the backend as data, but instead of the CRUD pattern, we have a much more rich query language to use. It also tends to be a bit more read-oriented, right, depending on the specific details of the query language. One of the things that makes this a lot better than the CRUD style is I can do some really complex things. Remember, in the object passing case, if I wanted to do a read that required some joining of data together, as a client, I have to do that work. I call this thing, I call this thing, I call this thing, then I figure out how it all goes together. But with a nice query language, I can send that query, and the server will do the work, and I'll get just the answer I need. Right? So that dashboard we talk about is suddenly so much easier for me to build. I can ask for all those pieces of data and get them back. The other big advantage to the query style is some of the tooling that exists. you can build some fantastic tools with this style. I can go to your API, and you can give me a tool that lets me work with the data in real time. So I create a query, and you show me the data. I say, oh, so that's what the data looks like. I change the query, you show me, and now I can take that query I was playing with and drop it right into my code. Right? Suddenly I've got this accelerated way of building a client application. And really, again, if we're going to be very data-centric, you can see why people who were building URI style apps might be very interested in the query style. It's solving the same problems, but giving you some additional usability benefits. The limitations are similar, I think, to the URI style. One of them is that it really depends on the query language itself. If you don't like the query language, you're not going to like using that API. There's some other interesting implications to me, things like performance implications. What happens if the client constructs a very complex query that ties up our resources on the back end? You know, is that okay? How do we prevent that from happening? Because we no longer really have an API, we just have a query point. If I'm designing an API, I can help my client make less mistakes. If I'm designing a query endpoint, I'm just saying, hey, here's some data. You figure it out. Right? The last style I want to talk about is the event-driven style, which is really quite different from the other four. There's a whole host of patterns I'm including in this bucket. But I'm talking about in the general sense because we're starting to do a lot more of this, and it is different from those primarily client-server patterns we just talked about. So in the event-driven style, we're talking about anything where I'm getting notifications and acting. So that could be a WebSocket, or it could be MQ, or it could be something like working with Kafka, right, and event sourcing implications, implementation. Our interactions are primarily asynchronous, so we're not doing block and wait. We're sending stuff out, and we're receiving things. In terms of protocol stack, I'm going to be very general here. Usually you have some kind of infrastructure that helps with sending events, some kind of transport protocol which just sends data, and then our design is often really in the event message itself. That's the only part where we engage our design brain outside of building the architecture. Usually senders have no knowledge of their receivers, so they're publishing out into space, right, into an ether or into a mesh. And whoever is going to find that useful, that message useful, picks it up and then reacts to it. The primary constraint, at least when I think about the style, has to do with time, that events are occurring in the past. If an event occurs, it's already happened. You can't change the past. Right? So student record deleted or something like that. It's not a request. It's not someone saying, I would like to delete a student record. I'm being notified something has happened in the system. And that changes the way you think about interactions. In terms of common implementation, I mean, it's broadly similar to the generic picture I sold you, right? That there's some kind of infrastructure and we publish messages and they get transmitted to receivers. And you might care about how your event is designed. What's interesting to me, I don't see a lot of people talk about this, but it's obviously important, right? The design of the event message is the interface, really, because that's what I'm coding to, that's what I understand. There's also very little like standards or conventions here. As far as I can tell, every organization does this in their own unique way. So again, it means if I build a component to process events, it processes your events for that set of components that talks that way. Maybe in the future there's opportunity to turn this into something more generic. Maybe there could be semantics involved, but I don't see that happening today. I first started talking about this again because of IoT. That spurred some interest, right? Oh, you know, things that happen in real life are primarily event-based. A light turns on, we react to it. But I don't talk as much about IoT anymore. I don't think that means IoT is not happening. It's just the people I talk to are not talking about IoT as much. They're talking about microservices a lot. And that's where the event-driven architecture seems to really come into its own, especially when we're talking about data, synchronizing data. There's a lot of good uses for it. And I'll show you an example of that a little bit later. We'll get to an event-driven example that highlights that. This style is useful because it allows us to decouple some things. In the client-server pattern, I'm talking to a server. In the event-driven pattern, I can loosely couple at least at the level of who am I talking to, right? Now I'm talking to a universe, to a mesh. I can also start to introduce things like decentralized messaging systems. I can improve reliability. I'm not talking to a server, I'm talking to an eventing system, right? And we can build that to be more reliable. And just in a minor way, we can even create UIs that feel more performant because our UI reacts to events instead of polling and checking and seeing what's changed. Some of the challenges are this way of thinking about what has already happened. So if I ask you to perform validation as an interaction, suddenly that's harder. You can do it, but then you need to think about inverse possibilities. Something happened, now how do we undo what happened because we don't like what happened? Right? That's a different way of thinking, it's more complex. And generally the architecture and infrastructure get more complex too. We need more components, more server infrastructure, more things to understand. And that means things like performance, scalability, and reliability depend a lot on this eventing infrastructure we build. When I think about these 5 styles, I use metaphors in my head. I don't know if this is useful for you. This is just how I like to think about them. For me, the tunnel style is like Java programming, call a function. The URI style is like dealing with data objects. Hypermedia is like browsing the web. The query style is like dealing with the database, and the event-based style for me is like programming a GUI where it's on click and you react to what happened. Just before we close, I think I'm a little running over, but I'm going to show you some examples because these might help. For the tunnel style, right? One of the ways that people are using tunnel style API often is for this kind of case. So here we have a microservices architecture, and we have something that's responsible for compiling responses together. So we can imagine this is an API that someone outside of our organization is using. To create a response to an API request, I'm going to talk to 4 services. In this architecture, we decided each microservice will have an RPC endpoint, maybe Google RPC. Why would you do that? There's a couple of reasons. The first is it makes publishing new interfaces a little cheaper for our service owners. We're saying to them, you can use this tool, you just change the IDL, and it spits out a little service proxy, and you tie yourself to that. You don't need to maintain a lot of documentation. Just give me the IDL when you finish it, and I'll be able to code to that, because I can generate my own client. We're also going to make this assumption that the composer team, this thing, is the only thing that gets impacted when these things change. So in my hypothetical example, the services are not talking to each other a lot. Our scale of consumers is very low, right? So it means I have a team who's responsible for constantly updating that composer whenever the backend services change, which should also ring some alarm bells, right? That's a potential bottleneck. But we decide in this architecture that's okay. We can manage that bottleneck. We'll keep the flow of change high enough that this bottleneck doesn't become an issue. We're also saying the people outside of our organization are shielded from this. So they don't know we're doing RPC back here. They're using whatever API we expose. And lastly, we can start to optimize the messaging speed. We choose an RPC protocol that lets us get a really high number of requests per second. So I can serve that API call very quick. Now, I'm not saying this is how you always have to do it, but this is one case where the benefits of the tunnel style might make it well suited for an architecture. The URI style classic case is something like this, right? We've got a complex platform. We want people outside our organization to be able to use our things, so we give them the URI style. Here's a nice banking API. Why would you choose this style here? Well, it's going to be familiar to people. They're not going to be shocked. They understand about CRUD and HTTP. It's pretty well suited for these simple things we want to do, view transactions, view balances. And honestly, there's not a whole lot of motivation for us to make an API where you can write some code and then easily switch to another banking API, right? So I'm not saying on purpose we don't want people to switch providers, but it's not a huge problem for us that they have to write new code to talk to another bank, right? At least today. Maybe that will change in years. For the hypermedia style, you might have a case where you need to present different user experiences to different users. So imagine I create an application, and there's an admin role and a user role. And it's the same application, but they have different workflows and slightly different UIs. Obviously, I can roll out totally new clients, but Hypermedia gives you the chance to keep the client the same and just change the backend, which would be very nice if that's a market differentiator. Imagine a scenario where being able to onboard a partner and give them their customized UI very quickly makes you a more valuable solution provider. For the query style, I mean, the obvious case where it's useful is if you had a lot of graph data and you're primarily serving graph data, then something like GraphQL seems like a good fit, right? It's why the people who started GraphQL used it. It could make sense for you as well. And then the last one is this event-driven example. As we start to have many services, we're told for microservices it's nice to keep the data with the service. It's actually really hard to do, keeping all the data synchronized. Eventually, you're going to end up in some pattern like this, where you'll have a service with some kind of cache, and that cache is going to be built through notifications. And you might build that cache up at the beginning by replaying the log of everything that's happened, right? This CQRS, event sourcing kind of pattern, turns out to be incredibly important if we want to decentralize data. Okay, so those are the styles. I think a lot of common sense goes into picking which one you would use for a particular context. But think about it in terms of those qualities we went over: scalability, consumability, usability, reliability, performance. And primarily use your head, right? Make these kinds of decisions not based on only what's popular. I'm not saying that doesn't matter, because we're all trying to hire people, right? So popularity matters. But make decisions based on architectural fit. All right? Those are 5 API styles, and I'll take any questions if there are any. That's a difficult question for me to answer because of my relationship with one of the API management vendors. I think I've seen organizations that have talked about it already, yes, at some of the conference events. I've seen one company that started just to do that. So if there is a demand, it will be addressed. Can I put it that way? If people want it, I'm sure it will show up, yes. Yeah. I have a question for you then. We'll do it with our hands. How many people would say that they're working on microservices architecture? Okay, it's about 5 or 6. All right, interesting. One more hand. Oh, for the box. Okay.
What's your point of view for microservices architecture for more or less in the future, in the short term, or medium term actually?
I think it's a great thing for software vendors, like any of these things are, right? I'm sure people sell a lot of products. But I also like the mentality of it. So when we talk about microservices in our team, we talk about speed, safety, and scale. You know, making change faster without breaking things. This seems like something that will be important to all of us. The thing I find it's less important to say you're doing microservices, more important to build evolvability, changeability into the architecture. that's what I'm most interested in. And from what I see when I go out and do work, everyone is taking steps towards this. So maybe some people start with DevOps type of work. Other people start with microservices. Other people are just solving problems. But we all seem to be going to the same optimization. So I think we'll see more of this kind of architecture. What could change it all is if fundamentally some constraint changes for us. Right now we're all trying to be more cloud-like, but if the cost of building technology changes in a way we don't understand yet, then it would shift away. There's one at the back.
Thanks, Ronnie. You mentioned 5 API styles. Have you any anti-patterns or any classic mistakes or anti-styles that people are making at the moment?
It's a good question. That'd be a good talk.
Sorry about that.
I should admit, have you ever heard of Daniel Kahneman wrote this book, Fast Thinking, Slow Thinking? I'm primarily a slow thinker, right? I talk slow, I think slow. So off the top of my head, I can't think of a whole set of anti-patterns. They're kind of milling about in there, but give me a year and I'll get back to you. How about that?
Thanks.
All right. Just want to do the... Okay, my email address is here. There's my Twitter handle. I'm always open for input, questions, feedback. If I would love to hear from you if you watched this whole thing, you didn't understand any of it, because that's also useful to me that I've done something wrong. All right, so please get in